Hey everyone, and welcome. Have you ever had one of those aha moments and thought, man, I wish I could build an app for that? Or maybe you've looked at a huge spreadsheet and wondered what secrets are hiding inside. Well, that's what programming is all about, and today we're taking our very first step into Python, one of the most powerful and beginner-friendly languages on the planet. So, let's dive in.
So here's how we're going to tackle this. We're going to approach it just like learning any new spoken language. First, we'll get the right mindset, understanding what programming really is. Then, we'll get properly introduced to Python. After that, we'll learn some basic vocabulary, which in Python is called data. Then we'll cover the grammar, learning how to build sentences. From there, we'll write our very first program. And finally, we'll talk about something every programmer does, debugging. That's how you really get fluent.
Okay, so let's kick things off with the single most important idea, the one that comes way before you write a single line of code. Because, as you can see here, programming isn't really about the code itself, it's about the thinking that happens beforehand.
So I want you to just pause for a second and think about this. What do you think it is? Is it being a math wizard? Memorizing complicated algorithms? Typing at 100 words a minute? What's the number one most crucial skill? It's problem solving. That's it. At its very core, that is all programming is. A language like Python? That's just a tool. It's like a hammer, or a pen, or a wrench. It's what we use to describe our solution to a problem in a way that a computer can understand and execute. The real magic, the really important part, is the thinking and planning you do before you even touch the keyboard.
Okay, so if programming is all about solving problems, the next question is, what's the right tool for the job? We want a tool that makes it as easy as possible to turn our ideas into instructions a computer can follow. And for millions of people, that perfect first tool is Python. Now, to really get why Python is such a fantastic starting point, you gotta understand this idea of language levels. Python is what we call a high-level language. That just means its words and sentence structures are a lot closer to how we humans talk and think. On the other end, you have low-level languages, which are much closer to the raw ones and zeros the computer processor actually understands. Think of it like this. An English speaker learning Python is kind of like learning Spanish. The structure is familiar. Learning a low-level language is more like trying to learn to communicate with an alien. And this whole idea isn't just a happy accident. It's actually baked right into Python's DNA, in something called the Zen of Python. It's a list of guiding principles for the language, and it includes gems like simple is better than complex and readability counts. The whole point is to encourage you to write code that's clear and easy to understand, not just for the computer, but for other humans. And maybe most importantly, for yourself, when you look back at your code 6 months from now. All right, so we've got our mindset, we've picked our language, now it's time to actually learn some words. In programming, our basic words are different types of data. Let's start with the 3 heavy hitters you'll use all the time. First up, we've got integers, or int for short. Now that sounds a little technical, but it's super simple. It just means whole numbers. No fractions, no decimals. Positive, negative, or zero. Think of anything you can count. The number of people in a room, steps you've taken today, likes on a post. Next up, we have floats. If integers are for counting, you can think of floats as being for measuring. A float is just any number that has a decimal point. So this is what you'd use for things like the price of a coffee, a person's height, or a scientific calculation.
And last but not least for our basic words, we have strings. A string is just text. Any text at all. A single letter, a word, a whole paragraph. As long as it's wrapped up in quotes, Python knows it's a string. And pay close attention to that second example, 17. Because it's inside quotes, Python doesn't see it as the number 17. It sees it as the text character 1 followed by the text character 7. That's a really important difference.
So, let's do a quick recap here. We've got integers for whole numbers, floats for numbers with decimals, and strings for any kind of text. These 3 are the absolute fundamental building blocks. They're like the nouns of our new language.
Okay, so we've got some words down. But just having words isn't enough, right? You can't just shout, dog, ball, park. You need grammar to string them together into actual sentences. In programming, that grammar involves things like variables and statements. So what in the world is a variable? Well, probably the easiest way to think about it is like a labeled box where you can store a piece of information. Instead of having to remember a long number or a complicated piece of text, you can just stick it in a box, give that box a simple name, like a nickname, and then whenever you need that data, you just use the nickname.
And, just like any language, there are a few grammar rules you have to follow. You can't start a variable name with a number, for example, and you can't use special words that Python already reserves for itself. But honestly, the most important rule is that last one, the one you enforced yourself. Use meaningful names. Calling a variable x might be quick, but user age is 1,000 times clearer to anyone reading your code.
Okay, let's stick with our language analogy for a second because it works really well here. An expression is kind of like a phrase. It's a piece of a thought that boils down to a single value. So 2 plus 3 is an expression, and Python evaluates it and sees the value 5. A statement, on the other hand, is like a complete sentence. It's a full instruction that tells a computer to do something. So user age equals 25 is a statement. It says, hey computer, take the value 25 and store it in the box labeled user age.
All right, this is it. This is the moment we've been building up to. We have our words, our data types. We have our grammar, our variables and statements. It's time to put it all together and have our first real conversation with the computer. And remember what we said at the very beginning? It all starts with problem solving. So before we write any code, we make a plan, our algorithm. And for something simple like finding the area of a rectangle, the plan is pretty straightforward. Step 1, get the length and width. Step 2, multiply them together. Step 3, show the answer. Simple as that.
And here's what that simple plan looks like when we translate it into Python. See how it's almost a one-to-one match? First, we create two variables, two boxes, named length and width, and we put the numbers 10 and 5 inside them. By the way, those lines with the hash symbol are called comments. They're just notes for us humans. The computer completely ignores them. Then we create a third variable called area, and we store the result of multiplying length times width. Finally, we use a built-in command called print to tell the computer, hey, whatever is in the area box, show it to me on the screen.
And that's it. When you tell the computer to run this code, this is what you see on the screen. 50. You did it. You created a plan, translated it into instructions, and the computer followed them perfectly to solve a problem. You've just written a complete working Python program.
Now, of course, when you're just starting out, and honestly, even when you're an expert, you're going to make mistakes. It's just part of the game. In programming, we call these little mistakes bugs, and the process of finding and fixing them is called debugging. It is not a sign that you're bad at this. It's a fundamental part of the process, just like a language learner correcting their own grammar.
Most of the time, the mistakes you make will fall into one of these three big buckets. You can think of them as different ways to misspeak as you're becoming fluent in this new language. Okay, so a syntax error, that's basically a grammar mistake. You've broken a fundamental rule of Python, like forgetting a quotation mark, and the computer just throws its hands up and says, I literally can't understand you. A runtime error is when your grammar is perfect, but you ask the computer to do something impossible while the program is running, like dividing a number by 0. The program starts, but then it crashes. And then there's the semantic error. This one is the sneakiest. The program runs perfectly, no crashes, no errors, but it gives you the wrong answer. This means your logic was flawed from the start. It's like asking for directions to the library and getting perfect step-by-step directions to the bank.
And that really brings us full circle. We've seen that programming is so much more than just typing weird symbols into a computer. It's a way of thinking, a powerful tool for solving problems. You now have the absolute basic vocabulary and grammar to get started. You can read and write simple sentences in Python. So the only question left is the one that really matters. What problem will you solve first?